Yo, what's up guys? It's your boy Roger, back at again, going over another AP Calculus BC FRQ question. Today we'll be looking at the 2014 question number 6, dealing with Taylor series. And before I begin, I'd just like to give a quick shout out to Mr. Happ for giving us this project. And also just a reminder to have you guys drop a like, comment, and subscribe. So let's head right into it. Let's go right into this problem. The Taylor series for a function f about x equals 1 is given by the series n equals 1 to infinity of negative 1 to the n plus 1 times 2n over n times x minus 1 to the n, and converges to f of x for absolute value of x minus 1 is less than r, where r is the radius of convergence of the Taylor series. So let's first look at part A, find the value of r. So right now guys, we should be thanking the College Board that they are so generous and give us a problem like this. Finding the value of r is just simply the radius of convergence, not even the interval of convergence, which makes this problem extremely easy. So first thing I do is I go over to my paper and rewrite this Taylor series. I just like to do that, and I think it's a very good idea to do because it just helps you from just looking back and forth from the going guidelines to your paper, and you just have this power series right in front of you. So we know that when we're finding the radius of convergence, we always use the ratio test, where we do it's always n plus 1 divided by the original. And so we can see how we do a limit as n equals to infinity of the absolute value of that. They cancel out, and we get 2 times x minus 1 limit as n goes to infinity of n over n plus 1. Ends up being 2 times x minus 1 is less than 1, and x minus 1 is less than half. And because it is just the radius of convergence, we do not actually have to add the 1 to the other side. We simply know that it's going to be 1/2 once we have x just like that. So that's how we are going to find the value of r for this problem. So we can see guys that this should be a very quick problem. One tip is that when we're taking the test and we have a problem similar to this, we can try and finish it quickly so that we have more time to go on to the more difficult stuff, which we'll be going on to right now. Now moving on to part B. Find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f about x equals 1. First of all, guys, it's not finding the first 3 non-zero terms of this, but for f prime. It's a very common mistake, so we must make sure to always do f prime and read the problem. So let's move down to part B. We can see that f prime equals the summation of n equals 1 to infinity. When we do that, we just know we are taking the derivative of the x minus 1 to the n. So it becomes x minus 1 to the n minus 1. The n gets right in front and gets canceled out with the n on the bottom. And we get this. This is our f prime. And guys, once we've solved that, we have already solved half of part B, which is the general term. Now we just need to find the first 3 non-zero terms. So we look back at our general term and plug in values. The first 3 non-zero terms. Another common mistake is that people will plug in 0 first, but this is actually not the case. We need to always remember to make sure to see what n is equal to. In this case, n is equal to 1, so we will be starting at 1, not 0. And we can see that when we plug in the 1s, when we plug in our 1, 2, and 3 value, I'll not be going over this due to time, but all you guys need to do is plug in 1, then plug in 2, then plug in 3. And once you do that, you will find that you end up with 2 minus 4 times x minus 1 plus 8 times x minus 1 squared. And so that is the answer to part B of this question. Now moving on to part C. The Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges for absolute value of x minus 1 is less than r. Use this function to determine f for x minus 1 is less than r. So guys, right now I know what you're thinking. You're thinking that, oh, this is a very tricky problem and that you cannot do this. But actually it's not that difficult. The question tells us that it is a geometric series. And what do we know about geometric series? We're trying to find the function to which the series converges for x minus 1 less than r. So we can go over and we can see that the geometric series is always in the form a over 1 minus r. A is the starting term over 1 minus the common ratio. And when we look back at our Taylor series, we can see that the common ratio is -2 times x minus 1. So that will be a common ratio. So first we need to find to which it converges for f prime. So we know that f prime is this. We know that, f prime of x, it would be 2 over 1 minus quantity of negative 2 times x minus 1, which simplifies to 2 over 2x minus 1, and that's what it converges to, just like that. And now we need to focus on the second part of the question. Use this function to determine f for x minus 1 is less than r. So what we need to do is that we need to take the f of x, we need to take the integral of what it converges to, and to put it into f of x, which we get ln natural log of absolute value of 2x minus 1 plus c. Now we need to plug in our known value. Looking back at the problem, we know that f of 1 is equal. Hey guys, I'm back. Sorry, it got cut off, and I will just be picking up from where we left off. So as I was saying, we know that when we look back, we can see that f of 1 equals 0. That's our known value. So what we're gonna do is that we're gonna set we're gonna find our c value, right? So we're gonna plug in we will be plugging in 0 to x, so we get ln of 1 plus c equals 0, and we know that c is 0. So basically we can figure out that f of x equals ln of absolute value of 2x minus 1 for absolute value of x minus 1 is less than half. And that's how we can go about solving this problem. And when we look back at the scoring guidelines, we can see that we have hit all these marks. We can see that we have determined R using the ratio test. We can also see that in the second part, we can see that we have determined the general term and the 3 non-zero terms. And lastly, we can see that we have completed this last problem correctly in finding what it converges to using the geoseries test, a over 1 minus r, and then solving for c. So guys, really we've done a very good job today of walking through this problem. And as you can see that these problems may look tricky and may look daunting, but when we break it down, these are actually very simple problems that we all know how to do. And just for extra practice, all of you can look up Paul's online math notes. It's a great place to do some Taylor series practice, your calculus textbook.